Hey everyone, welcome to your first digital lesson. This is section 10.1, angles of rotation. This is our first unit on our trig unit. Unit 10 is all of our trig stuff. We're going to take it hopefully nice and slow. So 10.1 is all about angles. So the initial part of this lesson is a review from geometry. So first up, sketching some angles. So the first angle that hopefully we all know is a 90-degree angle. So we put a little box in the corner. So let's call this 90 degrees. Another angle that hopefully we all know is 180 degrees. Straight line, so technically a dot in the middle. This angle would be 180 degrees. Something hopefully we also know is 360 degrees, so a complete circle. So let's say my angle starts here. And if I go all the way around to here, this is 360 degrees. So hopefully these are three angles that we've seen at some point. What we're going to talk about is we're going to start putting these angles into the coordinate plane. And we're going to think about these at an Algebra 2 level instead of necessarily on a geometry level. So hopefully just some vocabulary review. The initial side of your angle is where you start, so it's usually like the bottom of your angle. So for example, this is called the initial side. And the final side where you end up, so you started here and you went here, this is the terminal side. So for example, for this problem, your initial side is here. You started here and we went all the way to 180 degrees. So this is initial. And this side would be your terminal side. So I usually abbreviate terminal as term. Here, the interesting thing is you started here, but you also ended up here. So your initial side and your terminal side end up being the same spot because you started here and went all the way back around to your original spot. So your terminal and initial are the same. So you might not necessarily remember terminal and initial from geometry. I just want to review because we'll be using those two terms a lot in Algebra 2. So here's our initial where we start and we go up to our final terminal side. Hopefully this looks familiar. I had some printing issues at home, so my ink is kind of crazy colors, so I apologize. But hopefully you guys can see my three angles that I've got here. This first one. So the arrow tells us a lot of information. So they're saying that we started here and went up this way. You can probably guesstimate that this looks like it's 90 degrees. This is our initial side. This is our terminal side. And so all we've done, the only difference between just sketching angles and then drawing them on a coordinate plane is we can gather more information about exactly where this angle lives. And we can talk about, we're going to talk about positive angles versus negative angles. And so this one's positive because we start here and we go up. We're going in a positive direction or around the coordinate plane. We can say what quadrant this angle lives in. So real quick to the side over here, I'm going to review quadrants. So your first quadrant is here. This is quadrant 1. So I'll label this quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. My trick from elementary school that someone taught me was it's like a C shape. The order you go is it creates a C. So you start 1, 2, 3, 4. So this angle lives from the x-axis to the y-axis, and it lives in quadrant 1. We're just going to reference angles a lot in terms of quadrants. Technically, the terminal side is living on the y-axis. So more often than not, they'll reference what quadrant is the terminal side living in. Now, technically, it's not living in any quadrant right now, but most of your angle takes place in quadrant 1 here. The second angle. So if you notice, this one isn't starting here and going up, it's starting here and going down. So take a second and think to yourself, okay, instead of if it's usually going up, now it's going down, what do you think that means in terms of an angle in the coordinate plane? Well, hopefully, maybe this came into your mind. This actually means that it's negative. So this is going to be a negative angle. So down here, there's counterclockwise versus clockwise. So counterclockwise is going against the way that a clock would normally go. So this way. So this is counterclockwise. Clockwise is the opposite way, this way. So counterclockwise creates positive angles. Clockwise creates negative angles. So positive angles, counterclockwise. Usually this means you go from your initial side and up. Clockwise usually means you go from your initial side and down. So you start, usually, most of the time we'll start here on the x-axis, and we either go up or we start on the x-axis and we go down. And so this one we went up, so this is a positive 90 degrees. This one we're starting here and going down. And then for right now, we're just guesstimating, like, what size angle is that? Hopefully from geometry, remember that this looks obtuse. So obtuse is greater than 90 degrees. Acute is less than 90 degrees. Well, here would be 90. And because we're bigger than that, we're going to say that this is obtuse. And I guesstimated this at about 135 degrees. But remember, is it positive or negative? It should be negative because we started the x-axis and went down. And then lastly, I have this one. So I like this one because let's ask ourselves, here's our initial side. Here's where we started. And the way that you can tell where you're starting is if you look at the arrow, wherever it's pointing to, that's going to be your terminal side. Wherever it just starts, that's your initial side. And it's usually always on the x-axis. So we're starting here on the initial side, and we're going down. So we're going down and all the way around. So remember, going completely around is 360 degrees. But if you look back, we started and went up. So this is positive 360. We start our initial side and we go down. So we know for sure that this is going to be a negative angle. All the way around would be 360 degrees. I'm going to guesstimate this at negative, like 320. Sure. This looks like negative 320 to me. So let's recap real quick. For our angles, let's imagine on a coordinate plane. So let me pick up some colors. So if we always start here on our terminal, or on our initial side on the x-axis, from here to here, this would be 90 degrees. If we started on our initial and went all the way over here, this would be, it's a straight line, so a straight line would create 180 degrees. One that we don't talk about very often, even in geometry, is we very often talk about 90 degrees and then 180 degrees. But what if we went like to here? So to this axis. So we started over here and went all the way to here and created this angle. Well, each quadrant is how many degrees? So we went from 90 to 180. Well, this is 90. Just this corner is also 90. So 90 and 90 make 180. If we went 3 quadrants, 90, 180 plus another 90. What's 180 plus 90? 270. Oh, my pen's dying. 270. How many pens do I have? We'll make this green, a different green. 270. And then once more, all the way around will be 360 degrees. So you end up back here. So angles in the coordinate plane are usually broken up by these 90 degree chunks. So the first quadrant is 90 degrees, 2 quadrants is 180, 3, 270, and 4 all the way around would be 360. Remember, 360 is just 90 plus 90 plus 90 plus 90. So we're going to use these 4 angles a lot. The one that we probably know the least about is 270. So if you start at the x-axis over here and go around 3 quadrants, you have 270 degrees. So I want you guys to, if you can, pause here and try to sketch the following angles. So think about 85 degrees Well, we know what 90 degrees looks like, right? So 85 degrees, would it be a little bit more, a little bit less than 90? Where do you think that would live? Negative 45 degrees. The first thing we probably notice here is the negative. So if it's negative, you need to ask yourself, which direction are you going? So you start on the x-axis always here. Are you going to go up or are you going to go down? And 45 degrees. Well, the first chunk that we know is 90. Is 45 greater than 90 or less than 90? So where do you think that's going to live? And the last one, 300, is positive. So we're going to start on the x-axis and go all the way around to where we think 300 is going to live. My hint is, well, if this is 270 to the y-axis and the negatives, and all the way around is 360, well, let's try to think about where do you think 300 degrees might live. So pause for a second, pause this video, and try sketching those. All right, so I'm going to create some coordinate planes. And we're going to try sketching our angles and then labeling what quadrant the terminal side is in. So I always start here on the x-axis. So this is our initial. We always start on the positive x-axis. And we're going to go positive 85 degrees. Well, if this is 90 degrees, then I think 85 would probably live somewhere about right there. To me, that says that's probably about 85 degrees. All right, so negative 45 degrees. So I start with my initial side on the x-axis. And then remember, if we're going negative, that means we're going down. So we're going to start on this initial side and go down. Well, whether we're going positive or negative, one quadrant is 90 degrees. So if we're going to start here and go down to here would be 90. So if I went from here to here, that would be 90 degrees. Well, let's think. 45 is less than 90. And it's actually exactly half of 90. So I would say that negative 45 degrees would live right here. And then lastly, 300 degrees. Well, like I said before, we know that the y-axis and the negatives is 270. So here's my initial side. If I go around to here, that's 90, 180, 270, and all the way around would be 360. So from 270 to 360, where would 300 live? Probably about like right here. Sure. So I'm going to call this angle 300 degrees positive. So far, let's just recap real quick. All we've talked about is angles. Angles on the coordinate plane, thinking about them as positive or negative in terms of going clockwise or counterclockwise. And so hopefully we remember a little about angles from geometry, the difference between right angles, obtuse angles, and these are like super obtuse angles. So going like negative 320 degrees is saying like, oh boy, this is a huge angle and it's like really big. We might get thrown off by wanting to talk about this acute piece, but actually what we're trying to measure is this outside big angle. And we kind of see that down here. So here's like the acute angle of 85 degrees, but if we wanted to, we could also compute the big angle on the outside. That's just not the one that we were asked for. So it takes a little bit of a changing of mindset of thinking about there is a little angle that seems very obvious, and then there's this big angle on the outside that we can also talk about. There's like a really big obtuse angle, like bigger than a like 180 obtuse angle. Negatives, so instead of just going up 45 degrees, we went down 45 degrees. So starting on your x-axis and going in the negative direction instead of the positive direction. And then, like I said, this is just like that really big obtuse angle. There's this acute one right here that's some negative angle that we could also consider. But we wanted to know about 300 degrees, so we started here and went way big all the way around to what we think 300 degrees might look like. So the next thing we're going to talk about is this thing called a coterminal angle. So coterminal angles are angles that have the same terminal side, but go around more than once. And what do I mean by that? We can go around the origin, so the origin's a dot in the middle, we can go around as many times as we want. And as we go around, we're picking up all of those angles. So like I said, going one quadrant is like going 90 degrees. And then to here would be 180. This would be 270. All of it would be 360. Well, you can keep going. You can be bigger than 360 degrees. So at 360, we could keep going around and around and around. And so that's what I'm going to show you guys here. So this angle, let's take a look. So here's the initial side. So we're starting here, and we're going up. So if we're going up, that means it's a positive angle. And to me, this once again looks like 135 degrees-ish. Halfway between halfway between 90 degrees and 180 degrees is 135. Because if you think about it, it's 90 plus 45, so you get 135. And this looks like it's about halfway, so I'm going to call this 135. And that's just something that you guys will pick up with time. Your homework problems to go with this section have some practice problems about like identifying what you think the angles might be. And all it really takes is reasoning, like this is 90, this is 180. So what might this be? Well, it's halfway between, what's halfway between 180 and 90? 135. I'm going to call that good. And a coterminal angle is saying that there are actually infinitely many angles that have this specific terminal side. So to show you guys, for example, let's say that I started here and I went all the way around once. So I made from here to here is 360 degrees and then ended up here. So I have like a big swirl. So I went 360 degrees plus the 135. So 360 plus 135. I'm using my calculator because I don't want to be wrong. 495. So this whole angle would be 495 degrees. So this is what it means to be coterminal. That means that they live on the same terminal side. They're coterminal. They're like, they're sharing their terminal side. And there's infinitely many. You could keep going around and around. You could go 360 and then another 360 and then a 135, or as many 360s as you want to go and then that 135. So this number can get really, really big. And also, if you think about it, it can get really, really small. And by that I mean in the negative direction. So if you start on your terminal side and you go down instead of up, ask yourself, what kind of angle does that make? Well, it'll make a negative angle. Well, if we go backwards, let's think about how much backwards we went. So there's a couple ways to think about it. All the way around the circle is 360. So what's 360 minus 135? 225. So this is like going negative 225 degrees. And hopefully you guys might have caught on to the trick. The trick to finding any coterminal angle is to add or subtract 360 degrees. So if you want positive coterminals, positive, you add 360. If you want negative ones, you subtract 360. Oh, sorry. So all a coterminal angle is it's an angle that lives on the same spot, but you can go around and around as many times as you want in the positive direction or the negative direction. And even in the negative direction, we could have gone around the negative 225, or we could have done a whole negative 360 and then the negative 225, or as many times around in the negative direction as you would like. So maybe pause here for a second and see if you can find two coterminal angles of these two. They can both be positive, both be negative, one positive, one negative, whatever you guys would like. Let's say I am at negative 40 degrees. Find me two other angles that share the same terminal side. All right, so if we think about it, I'm just going to sketch this real quick. Let's call negative 40 degrees. It's a little bit less than 45, so a little bit less than halfway. So we'll call this negative 40 degrees. So coterminal means let's start with your terminal or your initial side, and we could go positive. We could go negative around more than once and end up at the same spot. Or you could go around multiple times. So all you have to do is you have to take negative 40 plus 360 degrees. You can do negative 40 minus 360 degrees, you could do negative 40 plus 360 plus 360 plus as many as you want. So negative 40 plus 360, where does that put you guys? What's 360 minus 40? Gives us positive 320. So one of them is 320 degrees, and that's if we went the positive direction all the way around positive to negative 40 degrees. And what if we gotten more negative? If I went around once and then did the negative again, negative 40 minus 360, negative 400 degrees. 450. Well, think about it. 450 degrees. We've gone around more than once because once around is 360. So let's see. If we sketch that, once around is 360. So what's 450 minus 360? Went up with 90 degrees. So that means we've gone a 360 and then another 90. So we've stopped here. So this is our terminal side that we care about. So this technically is 450 degrees. So I think the obvious answer is coterminal angle is just 90, right? One of them is 90 degrees. How could we get that? Well, that would be 450 minus 360 gives you 90 degrees. What else could we do? We could go backwards once. So we could do 450 degrees plus 360. We could do 450 minus 360 minus 360, whatever you guys would like to do. 450 plus 360 would say going around another time would be 810 degrees, which is huge, right? So that means we would go around once and then around another one and then that 90. So you guys can do it however you'd like. On your homework, some of them get kind of big and they ask you to find ones between 0 and 360. So we're going to try one like that here in a minute. But yeah, the trick to coterminal is you can go around a circle as many times as you'd like. And all you have to do to find the actual angle is add or subtract 360 degrees as many times as you'd like. So on the back of our notes, find an angle between 0 and 360 that is coterminal to negative 1345. Okay. So right now we have a negative angle and we want to end up with a positive one. So let's ask ourselves, should we add 360 or subtract 360? If we subtract 360, we're going to get more negative, and that's not a good thing. So I'm going to add 360s until we get something positive. And so my trick is, we got negative 1345 plus 360. What do we get? Oh, still negative. So I'm going to add 360, add 360, and I'm just going to keep adding 360 till I get something that lives between 0 and 360. Oh, perfect. So now I end up with 95 degrees. Now, technically, everything on this list right here is coterminal. So, negative 1345 is the same thing as negative 985, negative 625, negative 265, 95. And we could also keep adding. Now we're at 455, but that's bigger than what the problem's asking for. They're asking between 0 and 360. So I'm going to go with 95 degrees. Now, why might we care about the coterminal angle between 0 and 360? Well, those are the ones that are the most obvious to us, right? We know best what 95 degrees looks like. Here's 90, 95 would be about right there. So the reason why we use coterminals is because a lot of times they will give us this big one, and we want to know, okay, well, if I want to graph that on a coordinate plane, where does that terminal side really live? Oh, 95 degrees. Okay, so far it's just been a lot of angle work. We're now going to take that angle work and apply it to some trig. So in geometry, we learned about some trig functions, sine, cosine, and tangent. So hopefully you guys, maybe you learned the mnemonic device SOHCAHTOA that tells you based on a triangle, what are our trig functions representing? And so this is specifically our right triangle trig. And we're actually going to make some right triangles out of our angles. So in this diagram, here's our angle. This is actually our 135 degree angle. But if you look, there's a dot up here. And what we can do is we can actually make a right triangle out of that piece of our angle. Wow. And if we know this coordinate, this is some x comma y coordinate, this leg is represented by the x distance, this leg is the y distance, and then this is the hypotenuse. Here's our right angle. Now, does somebody out there remember how to find a hypotenuse? Hopefully. You probably learned this thing called the Pythagorean theorem. Which says a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. So hopefully you remember our Pythagorean theorem. Specifically for our class, we're going to call this y, x, and I'm going to use r. So for our class, we're going to say x squared plus y squared equals r squared. And I'm just changing the letters because it'll make more sense for us moving forward, because this is an x distance, this is a y distance. So we're going to label our sine, cosine, and tangent values. And we're actually going to use, for our right triangle, here is our angle. And I'm going to label my angle theta. So real quick on the theta thing. Hopefully in geometry, you talked about theta. Theta is a Greek symbol. It's like an O with a line in the middle, and it's spelled theta. And all theta represents in Greek and in mathematics is an angle. So this is just angle. So it's some general angle. We don't know, well, actually, we could figure out what this angle is, but we're just going to generalize that this is our angle theta. This is our reference angle, so this is what we're going to base our sine, cosine, and tangent values, is this inside angle right here. You could pick this one. It doesn't matter. The problem will tell you which one's which. So right now we're going to label this as theta. So for my sine value, if I wanted to find sine theta, and remember sine is usually abbreviated sin, of theta, my angle that I care about. Sine is O over H, opposite over hypotenuse. So opposite is the side across, so this is our opposite side. And then when we get to A's, A represents adjacent. This is going to be our adjacent side, and we've already labeled our hypotenuse as this side. So opposite, adjacent, and hypotenuse. So hopefully this is something you guys remember. And obviously it's been a while, so if you don't remember it exactly, that's okay. If you need more information about right triangle trig, I can give you guys stuff. So sine theta is the opposite side over the hypotenuse. Cosine is cosine theta, which is the adjacent side, and I usually just say ADJ for adjacent, over H is hypotenuse. I usually say hypotenuse. And tangent is opposite over adjacent. So tangent theta is opposite over adjacent. And that's just in terms for this triangle. Now, we will need to know these lengths. So the opposite side right now is y, and the hypotenuse is r. The adjacent side is x, hypotenuse is r, and opposite is y, adjacent is x. So what we're going to do in Algebra 2 is we're actually just going to fill these values in given the triangle. So this is a general example right now. So we're going to try some of these. So given that the point -4, 5 is on the terminal side of an angle, theta, find the exact values of the following, so sine, cosine, and tangent. So for these problems, we're going to graph this point. So let's sketch. So I'm going to sketch a coordinate plane. And on your guys' homework, you'll have to do the same thing. So the first thing I would do on these problems is sketch a coordinate plane. Plot -4, 5. Sure, it's like somewhere right there, right? Let's guesstimate. And they're saying that this is a terminal side of an angle. So we started here and we went like that. So here's an angle. And just like up here, we can turn this into a triangle. Yay. And we're going to call this our theta angle here. And so what's awesome about this is we know that this distance here, from here to here, was -4. So my adjacent side is -4. My opposite side is 5. But the problem is do we know this length? Does the coordinate tell us anything about this length? No. So we have to use our Pythagorean theorem, buddy. So 5 squared plus -4 squared equals, this is r squared. 25 plus 16 equals r squared. 25 plus 16 is 41 equals r squared. How do we get r by itself? We take a square root. So I'm just going to say r equals square root 41. And it's perfectly okay to leave it like this. Like, we're just going to leave the radical. It's a decimal. Like, why make it an ugly decimal? We can just leave it a radical. So our hypotenuse value is square root 41. And also, when you guys start to do some of the online practice, they'll just have you type in square root 41. Remember, the way to type in a square root is SQRT, and then parentheses, whatever. Or I think that there's a little drop-down menu, and you can click on the square root button. So, sine. Well, we know that it's opposite over hypotenuse. The side opposite theta is 5. The side adjacent is -4, and this is my hypotenuse. If you guys need to label your sides, label your sides. So opposite over hypotenuse is 5 over root 41. And that's your answer. That's it. Cosine is adjacent over hypotenuse. The adjacent side is -4. Now remember, the negative is important here, right? Because we're specifically referencing this coordinate -4, 5. And the distance according to the coordinate plane is -4, not positive. Because we're going to be working specifically in this coordinate plane now, the negatives are important. So adjacent over hypotenuse would be -4 over root 41. And then tangent is opposite over adjacent. Our opposite side is 5, adjacent is -4, 5 over -4. And that's it. So all we're having you guys do initially is just identify the pieces. So you're going to have to do a little bit of work with Pythagorean theorem to find the hypotenuse in some problems, or maybe a different missing side. And then all you're doing is identifying the pieces. Opposite over hypotenuse, adjacent hypotenuse, opposite over adjacent. So the last type of problem that I gave you guys for this week is ones like these. So if tangent theta equals 7 over 4 in quadrant 3, find sine theta and cosine theta. So what we're going to do is, okay, so there's some coordinate here that's making an angle in quadrant 3. So remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So there's some coordinate here that's making an angle that's like this. And we can turn this into our right triangle buddy. So theta is living in here. So this is opposite, this is adjacent, and this is the hypotenuse. Well, tangent tells us some information. So remember, tangent is opposite over adjacent. So that means if it's 7 over 4, the opposite side is 7, and the adjacent side is 4. And all we have to do is use that to find the hypotenuse. Now, technically, there's a couple things we need to remember, because if we're in quadrant 3, is this distance positive or negative? Well, it's actually negative, right? There's the negative x's. And if we're down 7, that means this should also be negative. But if it's, why is it positive 7 over 4? Well, -7 over -4, the negatives cancel out, and you get positive 7/4. So there's kind of a trick here, because I labeled it as in quadrant 3. So yeah, that if our coordinate is here in quadrant 3, this isn't the point 4, 7. It's the point -4, -7. So if we want to find sine and cosine, that means we're going to do opposite over hypotenuse and adjacent over hypotenuse. Well, we know the opposite side and the adjacent side, but oh no, rats, what's hypotenuse? Back to Pythagorean theorem. So -4 squared plus -7 squared equals your r squared, that hypotenuse value. 16 plus 49, 16 plus 49 equals r squared. 16 plus 49 is 65. Square root to get r by itself, so it's just square root 65. Not a nice number, it's a decimal, so I'm just going to leave it as square root 65. So sine theta is opposite over hypotenuse, so -7 over root 65. And cosine theta is equal to adjacent over hypotenuse, so -4 over root 65. All right, so this is a lot of trig review. There's a lot of geometry getting thrown at you guys in this stuff. So things to remember. SOHCAHTOA rules. If you need to come back to this spot, come back to this spot. If you guys need to write this stuff down and keep it handy, we're going to be using these for the rest of the school year. Having this diagram, this triangle, labels, adjacent, opposite, hypotenuse, x, y, r. Having the Pythagorean theorem. And then your homework is mostly these two types of problems. So coordinate point, -4, 5, labeling that this distance is -4, this is 5, and then using Pythagorean theorem to find the hypotenuse. And then finding the 3 trig functions using these definitions. And then the other type of problem is I give you one of the 3 trig values, and then you have to make the triangle yourself. Well, okay, it's opposite over adjacent, so I know my opposite and adjacent sides. They're telling me that it lives in quadrant 3, so that means it's here in quadrant 3. So I label my opposite, my adjacent, and then I once again had to find my hypotenuse using Pythagorean theorem. Sometimes you'll have to find a different missing side. So remember, using Pythagorean theorem, you can do, for example, like -4 squared plus b squared equals a number squared and solve for this missing one. So just make sure for these problems, you guys need to be sketching a picture, labeling, making sure that you have negatives where you need negatives. If you need specifically this stuff, have this stuff pulled up. Your trig functions and your diagram. If it helps you guys to write that stuff down, write that stuff down. Please, 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 if you guys have any questions, that's what our Zoom time is going to be for. You guys, I have office hours that you guys can Zoom me, or you can call me or email me for me to help you guys answer any questions. Your homework is on WAMAP. It is open, ready to go. There are hints and videos in there that are also helpful. You can Google this stuff, but please, please, please ask me questions if you need to. Hopefully 10.1 goes okay this week. Thanks, guys.